All right. Now, when we graph these linear equations, and the word linear is the word line. So when we graph these equations, the graph's going to be a line. So just make a note that the graphs will be lines. And we're graphing lines in a coordinate plane, a Cartesian plane. So this part right here is coming from 10.1. So the horizontal axis, remember what that horizontal axis is called? That's the x-axis. The vertical axis is the y-axis. All right, and remember the point where the two axes intersect is called the origin. All right, so that's going to be in 10.1 in one of those videos when I send it to you. All right, and in this plane is where you're going to start graphing some lines. All right, and a linear equation, the form of a linear equation looks like this, and the linear equations, since the horizontal axis is x and the vertical axis is y, you're basically going to look at two variables. So I'll have this form. I'll have the form ax plus by equal c. That's the form it's going to have. So all these linear equations, you can always write it into that form. Now what makes it linear, because next semester you're going to look at quadratic as well. And quadratic is not a line, it's a different shape. But what makes this right here linear is that the exponents of x and the exponent of y are both what number? 1. That's what makes it linear. If this was ax squared, then that would be quadratic. And that's going to be in the next course. And then when we take college algebra, you can look at other kinds of graphs. All right, so as we do these, you're going to notice that x can be raised to the first power, and y will be raised to what power? The first. And so these are lines. And you're going to notice as we go through this that to graph a line, you just need 2 points to graph a line. But we're going to use 3 because you could make an error on one of your points. And so if all your 3 points are correct, they all should lie in the same line. So that's why we tend to use 3. But really, to graph a line, you just need how many points? 2. That's all you need to graph a line. All right, so let's talk about this for a moment. Suppose we had y equals 2x minus 3. We had y equals 2x minus 3. The easiest kind of linear equations to graph is where one of the variables is already by itself. That's the easiest kind. So this is the easiest kind to graph because what letter is by itself? Y. So the easiest kind to graph is where one of the variables is already by itself. And so I want to graph this line. And remember when we solved an equation, when we solved this equation has how many variables in it? This equation has how many variables in it? 2. When we solve this equation, we are asking ourselves, what number plus 5 is 6? And so we said x would have to equal what? 1. Okay? And so here, though, I have 2 different variables. So if I asked you this, I'm going to use a t-table. So as we do these, you're going to see us using a t-table. And one of the things you're going to learn in section 10.1 is the idea of an ordered pair. Ordered, O-R-D-E-R-E-D, ordered pair. So order means alphabetical order for the most part, and pair means how many numbers? 2. It comes in pairs. And so an ordered pair is going to have this form. It will be a parentheses with a comma between them. And so the first number listed is going to be your x coordinate. Your x coordinate. Notice the word coordinate. And then the second one's going to be the y coordinate. And so when we do the t-table then, Since x is listed first here in the ordered pair, we're going to put x first. And then we put what next? Y. So always put it as xy. If you kind of change it, you may plot your points incorrectly. All right, so always put it as x, comma, y. And so what letters by itself here? Y. So what we're going to do to solve for y is I'm going to pick a number for x. In this case, it doesn't matter what number I choose for x. So give me any number for x. 2. So if x is 2, basically what you're going to do is wherever you see an x, you're going to plug in what? 2. So this is what you're saying. You're saying y equals 2 times x. What's x? 2 minus 3. And use the order of operations. I multiply before I do what? Subtract. What's 2 times 2? And what's 4 minus 3? 1. All right? And so when I solve this equation right here, x equal 1 is a solution. X equal 1 is a solution. How many solutions is this equation right here, this linear equation? Remember, this is a linear equation, right? This is a linear equation, but it only has how many variables? 1. This is also a linear equation, but it has how many variables? 2. It has 2 variables. They're both linear equations. When I solve this linear equations, how many solutions did it have? 1. So I want to talk about, well, when I solve this linear equations, I want to talk about, well, how many solutions does it have? Huh?
1.
Just have 1? Okay. So one of my solutions is this right here, 2, 1, right? Because if I plug in 2 for x and 1 for y, notice what happens. So y, what's y? 1 equal 2 times x. What's x? 2 minus 3. And the question is, are these two sides equal to each other? Yes. So that's a solution. But someone said that's the only solution. Remember when I asked you, I said this. I said, since y is by itself, give me any number for x. Someone else could have said what for x? 4. So if x is 4, let's see what we get. We get y equals 2 times x. What's x? 4 minus 3. What's 2 times 4? And what's 8 minus 3? So I get the ordered pair 4, 5. Is that also a solution? Yes, that's also a solution. It's a solution because when I plug 4 into x and 5 into y, the two sides equal each other. Watch. What's y in this case? 5 equal 2 times x. What's x? 4 minus 3. And what's 2 times 4? And what's 8 minus 3? And so those two sides are equal. So are there only 2 solutions? No. There's an infinite number of solutions. You could have said negative 3, right? If x is negative 3, let's see what we get for y. Y equals 2 times x. What's x here? Negative 3. Subtract 3. We multiply before we subtract. What's 2 times a negative 3? And what's negative 6? Subtract 3. Use your calculator if you need to. Negative 9. Negative 9. So there's an infinite number of solutions. So there's an infinite number of ordered pairs. So when I solved this linear equation, I was able to list the solution. So in the blank, all I said was x equal what? 1. Here, I can't list them because how many solutions are there? An infinite. So the way that we denote the solution is this idea. So watch. All right. So now once you remember to graph a line, how many points do we need? 2. But we're going to use how many? 3, just in case I made an error with one of these. Because if I made an error in one of them, then they wouldn't all lie in the same line. So then I would realize I did something wrong. Okay, I didn't print any graph paper, so I'm going to do that for next class period. Basically, what I want you to do is this. Just draw a x and y plane. All right, so x and y. So you have your x-axis and y-axis. And we're going to plot each of those ordered pairs. Notice I'm using the word ordered pair. So the first ordered pair is going to be what? 2, comma 1. Don't say 1, 2. You got to say what? 2, 1. You got to put what coordinate first? X, and you put what coordinate second? Y. Okay, that's important. That's going to be in 12.1, I'm sorry, 10.1 video when I send it out. So let's talk about how to plot those points, and that's also from 10.1. So a lot of this is going to be a review from what you're going to see in 10.1. So let's plot the point 2, 1. So to plot a point, I'll always start at the origin. Or start at the origin. And where's that origin located? Where the two axes meet, right here. And so when you look at the graph paper, what's going to happen is that just like a number line, if this is 0, where the two axes meet, that's 0. This is 1, this is 2, 3, and so on. So your positive numbers are to the right, and what are to the left? Your negative numbers along the x-axis. Along the y-axis, where are the positive numbers located? Going up, going up. Yeah. So you go above the x-axis. So that's 1, that's 2, and so on. And then below the x-axis are your negative. Okay? All right, so I want to plot the point 2, 1. So always start at the origin. And so we're going to start at the origin. And then I'm going to ask myself, and always start with x, with the x coordinate. What is this x coordinate right here? Positive 2. Okay? Since it's positive 2, that means I go to the right 2. If it was negative 2, I'd go to the left 2. All right, so I go to the right 2. And then y is what? Positive 1, so I go up 1. So here's the point right here. There's the point 2, 1. And that's also a solution. That's my solution. Now, on the worksheet, it's going to say label. Now, label does not mean just putting a little dot here. That's plotting. I plotted that point. Labeling means to tell me what those coordinates are. So what are these coordinates right here? 2, 1. So you're going to say this. You're going to say parentheses 2, 1. That's how you state a point, with the parentheses. Now, some students get confused because it kind of looks like interval notation, doesn't it? Yeah, so just be careful with the situation, with the context you're in. Here you're plotting points. In inequalities, you're listing it in interval notation. So that's not the same thing. That's not interval notation. That's a what? A point. 2, 1. All right, now let's plot the other point. What's the other point that you see? 4, 5. All right, to plot that point, again, where do you start? At the origin. And always do x first. So I start at the origin. Remember, x is your x-axis. That's a horizontal axis. So since 4 is positive, I go which way? To the right. So 1, 2, 3, and here's 4. So that's where I'm at. Now, don't put the dot there, okay? This is just where you're standing for right now. Then y is what? 5, so I go which way? Up. 1, 2, 3, 4, 5. So here's 4, 5 right here. Now you're doing this by hand, so you're kind of estimating where those little grids are. So when I give you the grid paper next time, it'll be a little bit easier to plot those points. Now, before we do the next one, let's talk about the word quadrants. So the x and y plane, the x and y axis divides the plane. If you think of this sheet of paper as a plane, which extends in all directions, divides this plane into how many parts? 4. These parts are called quadrants. Quad meaning 4, though, right? Quad meaning 4. And we named them counterclockwise. So we start here, the upper right. That's quadrant. The word quadrant, Q-U-A-D-R-A-N-T. That's also going to be in that video 12 for 10.1. So that's quadrant 1. Then this, we go counterclockwise. Then this right here is quadrant what? 2. This is quadrant 3. And this is quadrant 4. All right, so those are your quadrants. So those 2 points I just plotted were in which quadrant? 1. Quadrant 1. All All right, now let's plot the other point. So this time we have -3, -9. So where do you start? At the origin. Now, the x-coordinate is what kind of number? So I go which way? How many units? 3. So 1, 2, 3. Then my y is -9, so I go down 9 units. So let's see, that's 3, 4, 5, 6, 7, 8, 9. Now you got to make sure that all those spaces are equal, otherwise it won't lie in the same line.
Yeah, mine didn't do that.
Yeah, it's all right. The grid paper makes it easier to deal with. So -3, -9, so that's about, and then I'm at an angle, so I got to figure out where this thing is. Looks like it's about here. And so I'll plot a point. If it says label, that means I gotta write this as -3, -9, right? All right, and then you would use a ruler or straight edge, like maybe your ID if you're on a small grid. Now notice I estimated this, so it doesn't look like it lies in the same line. So I'm gonna have to cheat a little.
I have to make your dots bigger. That's what I had to do.
Yeah, so you didn't. So let's just say it's here. All right. Now one other thing I see people do is they do this, and then I take a point off, because when you're drawing a line, you got to use arrows. So make sure you draw those arrows. So draw arrows at the end. And so notice those 3 points. When we talk about those 3 points that we did here, this point, this point, this point, those were solutions, right?
Mm-hmm.
So that means then that all of these right here are what?
Solutions.
Solutions. So how many solutions are there?
Infinite.
Infinite number. Where do the solutions lie? On
On the
the line. So my question is this. Is this point right here that I'm pointing to, is that a solution?
No.
No. The solutions are only the number, or only the points that are located on the line.
Line.
All right? All right. Now, it took us a while to talk about this, but most of that was kind of talking about 10.1. Again, the easy kind is where the variable is by itself. So we're going to continue talking about this next class period, but I just wanted to start off talking about graphing linear equations. All right? Okay, so